Welcome to VKS Coding. In this video, we'll talk about WhatsApp system design. So I hope everybody know about the WhatsApp and everybody have used, but still I'll tell something about the WhatsApp. And it is kind of a one-on-one chat application like Facebook Messenger, WeChat. So basically, one user from his mobile app or desktop can send a message to another user. It could be a text message, photo, video, right, and document. And many other features are also supported, like sending a message to a group and voice call, group call, video call. So there are many features are available with the WhatsApp. So we'll proceed and we'll gather the requirement first and we'll proceed with our design. So let's go to the next phase of the system design, that is for requirement gathering. So in requirement gathering, we have to ask the few questions to the interviewer is like what kind of chat application shall be designed? It's a kind of one-to-one messaging, or it should be a group base. So interviewer can say it should support both, right? So basically he wanted to design for that will support both one-to-one and group messaging as well. Next question we can ask you with the interviewer is this a mobile app or it can work with the web app or it should work with the both? Then interviewer might say it should work with both, means mobile plus web, right? It should be supported in both the category. Next question we can ask is the group chat is supported? He can say yeah, definitely group chat should be supported. And next question we can ask like what are the features like he's interested in the chat application. So he might reply to on you is like one-on-one chat he needed it in it. Next he is might be interested in the last seen online offline status of the user. We can ask one more question is there any message limit for the size which the user will send? We can say yes. Interviewer might say yes, but we can confirm of the limit as well. So he can say like means 10,000 characters, something like that would be the message limit for each message for a text message. So we have confirmed here with the requirement. So if I frame it based on a functional and non-functional, so our functional requirement will become here is one-to-one send and receive, right? This will be the first criteria of the our application. Second is group message support, and we can ask as well one more thing like user need to be authenticated, right? Then only he can log into the system. So do we need to design a login system as well? So interviewer might say yes, I'm interested to know how you gonna authenticate and all. So we can also consider as user login. So we will concentrate on that also, how the user will log into the application. And one more functional requirement we can see last seen online and offline status. So this could be in similar kind of a category. So total we have a four functional requirement, and in non-functional requirement, it could be kind of scalability. Either it is designed for a small application, a small size, or for a larger audience. So definitely he might be interested in the scalability as well. And the next will be the low latency, because whenever you send a message, the message should deliver to the end user very quickly, and the response also send back to the user very quickly, and the system should be available, right? Then only the our application will work. So these are the category of functional and non-functional requirement that we have to concentrate on that while designing our system. So I hope we are clear here. One is the one-on-one send and receive feature we have to design. Second is the group message support should be there, and third is the user login system must be there. And the fourth will be the last seen online offline status should be shown for the app. And in the non-functional category will be the scalability, low latency, and the availability should be there. So now let's proceed further, and the next step will be the backup envelope. We have to compute basically what are the storage needed on all those things. So let's proceed further and compute those things. So in the back of envelope, first we have to find out the how many daily active users should be present for the app. So suppose the interval will say 50 million, right? 50 million will be the daily active user. DAU, you can say that in the short form. 50 million daily active user. Then here I have mentioned like one user, if suppose sending a 10 message to 4 people per day, then the how many messages per day will happen, right? So it is very easy to calculate. Basically, four user is there, right? So four user is receiving 10 messages. 10 messages, and how many user is sending in a day? So it's a 50 million, right? So this is the number which is per message. How many messages per day? So this is the number of messages per day. And if you compute this, this will come around 2000 million. And from million to billion, it will be 30. So it will be kind of 2 billion, right? So 2 billion messages per day we have to compute it, right? So suppose when we try to find out the storage space, suppose one message is containing 100 byte, then what will be the size is needed, right? So if you compute the size, then what we have to do, this 2 billion, right? This 2 billion is the you have to multiply this 2 billion with 100 bytes. So this will come around 200 GB per day, right? So this we have computed with the again with the same table, like whichever the TV belongs to billion and the million belongs to GB, like that kind of table. I'll means create one more video where I'll explain in the detail how the back of envelope we have to compute it, and what are the parameters we have to know before that computing it. So it will be make ease our calculation. And suppose we wanted to store the chat history for 10 years, then what is the storage space we need it? So basically this is the 200 GB we need it per day, right? So the now that is needed for 10 year we have to store it. So it is very simple to compute it. What we need to do is just multiply with the 10, because 10 year, then the number of days will be 365, then this is the 200 GB, right? 200 GB. Then if you compute this value, then it will come around 730 TB. So this is the actual storage space which is needed to store the chat history and all the other details for 10 years. So 730 terabytes. So this calculation will not be accurate, but we should know how to calculate it. So it will be good to know and explain in the interview, because they expect these things to be explained. Now let's proceed with the next step to understand how the client and the server communication will happen. So let's first understand the basics, how happens and what are the protocols are getting used. So and after that we'll proceed with the designs. So here I have defined the basic diagram. So here I have tried to show how the client and server will communicate. So here the sender is there, here is the receiver is there, and in between I have defined the chat service. So basically in the chat system, clients can be either a mobile application or a web application. Clients do not communicate directly with each other. Instead of each client connects to the chat service, and the each chat service, what it does, it will forward the message and it will store the message as well. So here I have given the example. Suppose this is the sender, this is the client one, right, which is sending a message. So this will be this is sending a message to the chat service. Chat service will store the message, and it will send the message to the receiver as well. So this is like a client 2. And suppose client 2 is not online, so whatever the message is stored in the client service, when this user will come online, this client 2, the chat service will send the message to the client 2. So this is the way how it works, but we need to deep dive more and understand the communication protocol, because in the chat system that is very important to understand it. So let's try to basically understand what are the protocols can be used and which we are going to select for our this WhatsApp system design while sending the message and receiving the message. So let's proceed and we'll discuss first with the HTTP. What is the pros and cons with the HTTP? Can we use the HTTP or not? So here I have defined again the user one, user A, and it is trying to send the message via HTTP to the chat service. So it is definitely able to send user A to the chat service. The problem will happen when the chat service try to send the message to the user B, because when the sender sends the message to the receiver via the chat service and it uses the HTTP protocol, because this is the client oriented connection, right? So client has opened the connection, sent the message, and it closed the connection here. So this is how the HTTP works. But since the HTTP is the client initiated connection, it is not possible to send a message from the servers to the this client again. So from here to here, it is not possible to send via HTTP. So this is the basic the HTTP problem with the HTTP protocol. So we cannot go with the HTTP protocol. So to solve this problem, right? To solve this problem from server to receiver, how we gonna send this message? We have a few solutions to it. One is a polling, next one is a long polling, and each having again pros and cons, and third one is a WebSocket. So we'll see one by one what are these features, what are these are protocols and how they works, and which one should we use for our use cases, right? So now let's move forward and discuss first for polling. So basically, polling is a technique that the client periodically asks the server if there are message available depending on the polling frequency. The polling could be costly and would consume a precious server resources. What happens actually? The client first will ask, "Is there any message?" Right. So here is a client, and here is a server. So client asks, "Is there any message?" Server will so no. If there is no message, then the connection will be closed. Again, the client will ask, "Is there any message?" Then server will say no, and again the connection will be closed. Again, client will ask the server, "Is there any message?" Right. Then if the server saying yes, then it will return the message, and again connection will be closed. So this is the how the polling will work. But in this case, what will happen most of the time, server will not have a message to send to the client, and this is a kind of a waste of resources, right? So and this is not scalable as well. This is not scalable. So this is the reason we cannot use it. So now let's proceed with the long polling and see how long polling works. So in long polling, the client hold the connection open until there are actually message available or a timeout threshold has been reached. Once the client receive a new message, it immediately send the another request to the server and restarting the process. So basically what happened here again, the client will be there and the server will be there. First, client will ask, is there any new message? And it will make a connection open, and it will wait for server will wait for new message. If it is there, it will return the new message. And again connection will be closed. Again the client will send a new message. It will ask and it will open the connection here. Again the client will ask for a new message. It will open the connection, and if the message is there, it will return it. Otherwise, if the messages are not available in the server side, then after this some threshold, right? Suppose 1 minute wait is over, then the connection will be closed. So either the message will be there within the threshold time, or if the threshold time is reached, then the connection will be closed. So this is the long polling. How it works is like first the client will open the connection. It will make the connection open for some threshold time, and then the connection will be closed. And between the threshold time, if the messages are available, it will send back the message to the client. So this is how it works. But again, this is also not scalable because the client hold the connection for a longer time. It is also not scalable. So let's see the third approach with the WebSocket, and that is the most common solution for sending the asynchronous update from the server to the client. So let's see how the WebSocket works. So in the WebSocket connection, it is initiated by the client, and it is a bidirectional and a persistent connection. First handshake will happen here. First client and server handshake will happen, then server will say in the acknowledge, and then bidirectional connection, bidirectional, and the persistence connection will be established between the client and the server. Through this persistent connection, and the server could send a update to the client, and WebSocket connection generally works even for firewall is in place. So this is the best I can say that, and it is scalable as well. So it works in our design when we want to send a message from client to server and from server to the client. So let's proceed further and see our revised design, basic design, how the client and server will communicate and send the message to each other. So here the chat service protocol. So we have decided we'll go with the WebSocket. So the sender will be connected to the chat service via WebSocket, and the receiver will also be connected to the chat service via a WebSocket. So both will be connected via WebSocket. Now let's compute the more of storages and try to identify like shall we go with the SQL or no SQL. So basically we need to first understand what type of DB we are going to use it, SQL or non-SQL, and also to decide that we have a sub parameters to take the consideration what is the read type and what are the write types. So read could be his chat history, group chat history, user profiles, right? These three type of read operation could be, and the write operation will be the sending of the messages, right? And the second will be updating the profiles. So these parameters could be for read write operations. Now we have to ask few question as when we wanted to go to the NoSQL or SQL. So the next question will be, are there any complex join query? Are there? So are there any? So the answer will be no. There are no complex join query. First question. Second question, we need to also check like how many C messages we have to support. So this is going to support for billions of messages, right? Billions of messages. And also we need a low latency, right? And we need a search capability as well for the chat history, right? So whenever we have this kind of a requirement, like when we don't have to perform any complex join query or any complex query, and we need to support for billions of users, and we need a low latency, a high availability, and search capability also, then this when the when the requirement of these kind of things, then we have to go to the NoSQL. So we need to go with the NoSQL DB. So let's see some data model as well, how we gonna save the messages in the DB. So I have defined the basic data model because for saving the message, first one will be the message ID, and this is basically generated by the we need a ID generator, unique ID generator. So this one I have covered in very detail in the URL shortener, how to design the unique ID generator. Please go and watch that. I have explained in much detail about how to generate the unique ID. So with the help of that solutions, we will generate the ID here. So message ID will be generated from with the help of the unique ID generator. Then the from and the to the user which is sending the message and to whom it is sending the message, and the timestamp at what timestamp it is sending the messages. And to store this NoSQL DB, suppose we'll use the this consistent hashing, right? So in this consistent hashing consist ring, so what will be the partition key, right? So we need to also identify which are the columns will be included in the partition key. Then only we'll be able to store the data and retrieve the data successfully, right? So that this from and to, if we combine together, then this will be our partition key. This will be a unique, and with the help of from and to, will combine together and make the partition key, and that partition key will be used to store the data on these nodes, right? Whatever we have used NoSQL DB. And you can ask also the message ID is also unique. So where can we use the message ID? So the message ID will be used in the particular partition. Suppose this is the partition. So we'll order means we'll rearrange, right? So we'll use the message ID to arranging here the messages, right? This partition key will help on which node the data will go. Suppose in the node 1 the data will go, then here how the data will be arranged. So using the message ID, the data will be again arranged. So I hope this data model and the partition key and the how the message ID will be generated, how the data will be stored. So I hope these things are clear. So let's proceed further and try to understand more. So now let's see. Here we'll see one messaging. How the one-on messaging will work with the user. Suppose user one is sending the message to the user two. So here I have given one example. Send message from to message. Message type. Message type could be one-on-one or group. So suppose user one is sending to the message to the user two. So before that, how it works? So what will happen is, so user one is first trying to authenticate. So user one is trying to send the login request to this login service. So user one will send the request to this login service. What login service will do? Login service will authenticate and send the one chat server detail from whatever the chat service will be available. So it will send the chat server detail to that user, and that this request will be happen via HTTP. And the next time the user will connect to the chat server, whatever he got the details via the login, and it will connect via WebSocket. So this is the login, how the login flow will work. Same thing will happen the user 2. User 2 will first request for the login, right? It will get the chat server detail, and then it will connect via the WebSocket. So once these user 1 and user 2 connected to the chat system, this mapping service, it will this chat servers will update to the mapping service, and mapping service will update this detail to in his DB. So what it will contain, it will make the details how the mapping is happening. Suppose it will user one is taken the chat server 100 and user 2 is connected to the chat server 200, right? So these detail is having with the mapping service. Now let's see the how the one-on-one messaging will work. Suppose user 1 is trying to send the message to the user 2. Then what will happen? User 1 will send the message to this chat server 100, right, via the web socket. Then chat server will ask the mapping service, is the user 2 is connected to the any chat server? Then it will say yes, it will mapping service will check his DB. Yes, user 2 is connected to the chat server 200. Then this chat server will internally talk to the chat server 200, and it will send the messages via the chat server 200 to the user 2. So basically this chat server 100 will drop the message to the chat server 200, and 200 will send the message to the user 2. So this is how this happy flow will work. So I'll reiterate one more time how everything will work. First, when the user will log in via HTTP, user will be authenticated and it will get the chat server detail. Then the user one will connect it to that particular chat server via the WebSocket. Same way the user one and user two is connected. Now when the user one wanted to send the message via the WebSocket, right? Then the user one send the message to one of the chat server. Then this chat server will contact to the mapping service. Mapping service will have all the detail for the user are connected to the chat server. Then that chat server will send that message to that particular chat server from that user is connected, and that server will send the message to that particular user. And what will happen if the user T2 is not online, right? In that scenario, what will happen? Then in that scenario, this chat server will store the messages in the DB, and whenever the user will come online in the same way, once the user will log in again, it will get the chat server detail, and whenever the chat server it is connected to again, suppose another chat server, right? Chat server 300, now it is connected to via WebSocket, right? User 2 is connected to 300. Now what will happen? The chat server will see is are there any messages in DB for this user too. If there are any messages are present, then this chat server will send those messages to the user too. So this is how the login as well as one-on-one messaging will work. So I hope these two things are clear. So I'll cover all over the design, but now I am trying to cover the each features, how individually works. Then I'll club together and explain all the things. So I hope this is the clear ones. Now let's proceed and try to understand the group messaging, how that is gonna work. So next one will be the group messaging. So what will happen in the group messaging is, so there will be a one more is a group service. A group service where what will have is like a particular group like G1 is having how many members, like it is having user 1, user 2, user 3, user 4. So this kind of information group service will have. And when the user is trying to send the when suppose user is trying to send the message to group 1, and that message is goes to the chat server, then chat server will ask the get group 1 detail to this group service. Then the group service will return how many numbers users are connected to this group, which are belongs to this group, how which all users are belong to this group. So suppose this user 1 is belong to this group, user 2 is belong to this group, user 3 is belong to this group, user 4 will belong to this group, and all this user is connected to the some chat server, right, individual, and this chat server will drop the messages to each individual chat server whoever the user are connected. So that's how the when the user 1 will send the messages to the group 1, all the users will get the details. So I hope this one is clear. So here user 1 is sending the message to the group 1, then to the chat server. Chat server will get the details of the group service from the group service, and group service will return the details of the users which are connected to this group. And once the so these are the details, and then chat server identify which are the chat server these users are connected. Then the chat server will drop the message to those chat servers, and those chat servers will transfer the messages to this group, these users. So this is the way how the group messaging will be supported, and it is done. So here we have covered group messaging support, right? So this is the third feature, right? First one was the login, one-on-one messaging. Third one is the group messaging support, and the fourth one is the last seen and the online offline status, how it is handled. So now let's proceed and check how that is gonna done. Before that, let's talk about the data model for the group messaging system as well. For group messaging, we'll store the message ID, group ID, user who is sending the message, and the message timestamp. And here the partition key for the group messaging will be the group ID, because it is a unique key, and we can easily use this group ID for a partition key for storing in a DB. Now let's proceed with the, I think it is very simple and straightforward. So how we gonna storing the data, right? So now let's proceed with the last scene and online offline, how we gonna handle it. So for this again we have a one more server. Suppose we call that server is a presence server, and it will have again a DB where it will store the details about the particular user, and the user will connect to the DB via the WebSocket, and this DB will have the details about the user, timestamp when it is connected, and what is the status. So I'll tell you how it's gonna work. So whenever the user first login, then after login, it will connect to the presence server. And whenever the user connects to this presence server, then the presence server update to the details. So suppose the user has logged in, right? Logged in at particular time like 10:00:01 a.m. So here first it will update it as a user A has logged in this particular time 001 a.m. and this is time online, like this is the time it is updated. First one is the login, second one is the logout. So when the user logouts, it goes through the user logout flow and the status is changed to the offline in the DB and the presence indicator will show us as the offline. So what will happen when the user will goes to the offline, then again the DB will be updated. The status for the same user will be offline. And one more thing we have to consider as the user can disconnect, right? It is common for the user to disconnect and reconnect to the internet frequently in short period of time. For example, in the network connection can be on and off while user goes through the tunnel and updating the online status for or on an every disconnect, reconnect would be make the present system indicator change often and resulting will be the poor experience, right? So what I meant here is suppose there is a tunnel, right? And from there user is going, right? So what will happen? Sometime internet connection is there, okay, here it is not okay, then again it is okay, then it is not okay. Then the user profile, what it will show? It will show online, then offline, then online, then offline. So it will be a poor user experience, right? So we should not handle via this way. We have to improve the way we should handle and update the status, which will be very user friendly, right? And user will be always, user should be happy as well. So we need to handle very properly this scenario. So what we can do is we can introduce the heartbeat mechanism to solve this problem. Means whenever the user connected to this WebSocket, it will keep on sending the heartbeat, right? The client will send the heartbeat to the server in every 5 seconds, right? First it will second, the next 5 second again it will send, then again net 5 second it will send. And suppose for 30 seconds the server will not get any update from the client, then it will make the status as a offline. So I think this approach will works because suppose this tunnel will take time to cross as like 10 second, then the user will be remain online, right? So will not change the status very frequently. So this is the way how we're gonna handle it. The last update will update the status here, and the status of the online and offline will be handled via the heart beating. And whenever the user logs in and log out, with the help of that, we can change the status and the timestamp that will be written. Cover, I think we have covered all the components and all the feature individually. Now we'll club together and we'll prepare high level design for the WhatsApp and discuss. So this is the high level design for the WhatsApp. So here is the client and here is the load balancer. Here is the user login service which is have a SQL DB. Here is a mapping service which has a Redis DB. Then again we have a chat servers which connected to the NoSQL DB. Then we have a presence system which is connected to the Redis. And again chat service are also connected to the group service as well, which have a group details. Now let's understand one more time how the flow will work. So first client will send the request to the load balancer. Then the load balancer first authenticate the user and it will return the details of the whichever the chat server is free. Then the client will again connect to the particular chat server and it will send the messages to the particular chat server. And chat server will talk to the mapping service. Mapping service will read this DB and whatever the other user connected to that particular chat server will drop the messages to that particular chat server, and from that server will be delivered to the message to that particular user. So similar way, once the client is connected to the after authenticating to the chat server, the client will be also connected to the presence system as well to update the status for his online, offline, and last seen. So this is the way the status will be updated, and this is the high level design. I hope I have also explained the individual component how they have interacting and how the messages are delivered offline status are delivered, how the group messagings are done, how the authentication are done. So this is it. And I think this diagram is also pretty clear. Like client sends the first message to the load balancer. Load balancer will redirect to the login service. It will authenticate and send the particular chat server for connecting to the client, and it will connect to the chat server and will send the messages. So how happens? So user one will be authenticated and it is connected to the chat server 1. Similar way, chat server 2 is user 2 is connected to the chat server 2, right? And when the user want to send a message, right, then the chat server will talk to the mapping service. Mapping service will tell the detail where the user 2 is connected. Then the chat server 1 will drop the message to this chat server 2, and that chat server 2 will drop the message to the user 2. So this is how gonna it is working. So I have explained this in very detail. So this is it about the WhatsApp system design. I hope I have things made very clear. So please subscribe my channel to get to know more about the system design, interview question and low level design. So thank you for watching my video.